So let's do a breakdown. Yes?
We need London Duncan for checkout, please.
She's on her way. London, I would watch this video so that you know everything that I just passed out. And because you're missing important foundational information for the rest of this unit. Okay. So first things first. These white sheets of paper, this is the lesson for today. This is the start of the lesson today. So be aware the white paper needs to stay out because that is the lesson. The blue here, okay, there are two different blue pages. Apparently I'm missing one of them. But the first one says, or one of them says, Geometry with Data Analysis, Equations Review Homework for 9 weeks test. Okay? This equations review homework is so that I can give you feedback before your 9 weeks test on how well you're doing with equations. This is due on Tuesday. You have a chance to ask questions on Monday. Okay? So this is not the exact stuff from the test, or it's the same exact concepts, but not the same exact questions. So use this to practice solving equations, creating equivalent equations, all that fun stuff. Is that clear? The other thing that I've already given you as a review is the other blue sheet. Okay? So the two blue sheets are the review that I'm giving you for the 9 weeks test. Okay? Really quickly, because apparently it did not save these notes as well. Make a note at the top of this page. Find the distance and slope between all the points, but also find the midpoint between all these points. There are 6 questions. Find the slope, distance, and midpoint between all pairs of points. Okay? So for all pairs of points, you're going to find the slope between them, the distance between them, and the midpoint between them. Is that clear? Okay? This, again, is review and to help you practice the skills that I've noticed we need the most help with. Alright? So the blue, when does that due? Tuesday. Okay? The blue is due on Tuesday. That is review homework to help you prepare for the test. It will not help you if you turn that homework in late. Turn that homework in on time. We clear? Okay. This orange sheet right here. This is, it should already say it on here, that's my bad that it doesn't. These are the big ideas from this unit on parallel lines, perpendicular lines, and transversals. This is to help you summarize the most important ideas that we have studied this unit and to help you study. Notice how there's a column here that says which lesson. There's another column that says definition or the major concepts or connections. You are going to fill this out for each term that we study.
Does anyone want a spirit ribbon for $1?
Thanks for asking that. So this is going to be due sometime next week. I have not decided when yet, but be aware that this is to help you study for the test that goes along with this unit. And here is another homework sheet. Just hold on to it. It's not due yet. Don't sweat it. Okay? I already have it printed. Second block. Okay. Terrence does ask you a question. If there is makeup work that you need to do, then
I'm sorry, I got it.
Hold up, real.
I just tried it.
okay.
Somebody got scared.
Step outside, get some water, see if that'll help you. Come back in. Let's do our best to learn. All right. This tan sheet is homework that goes along with what we are studying. I am not making it due yet because you have plenty of homework with the review homework. Sound good? Okay.
Yes, sir.
But you need to go ahead and start working on this tan sheet as soon as possible. So when is the blue due? Tuesday. Okay. The orange, that's your big ideas for the unit. The white is what we are studying today. And the 10 will be homework, so go ahead and hold on to it. Any questions up to this point? Okay. I did not. Sometime next week, probably. Depends on how quickly we move through content. Okay? In case you didn't hear me say it to Terrence, Terrence asked a good question. I already have the review homework printed out. If you need a or not review homework, I have the makeup homework that should have already been turned in. If you need lessons 6, 7, or 8, see me after class and I can give you a copy of what you're missing.
Is everything
No,
I'm missing?
you're gonna leave.
That's what I'm missing?
I don't know what you're missing. You should know what you're missing. If you don't know, then I can give you all 3 of them. Do you remember what you're missing, Anton? All of them? Okay. Hey, I'm only giving Anton his stuff right now because he's leaving early because of football. You get it from me after class. There we go. All right. So let's get started.
I only got 2.
Oh, I don't got one.
You only got 2.
Can I see this real quick? Can I see it real quick? Okay.
Miss King, how you doing?
You ain't no easy.
All right. All right. Let's look over. Let's talk a little bit about the parallel lines and just see what we originally were thinking.
What parallel line?
Well, the bell ringer was on parallel lines.
Oh, snap.
Just was a log in. So what do you know about parallel lines? 2 lines that are equal on both sides.
But don't touch.
They do not intersect at all, but run in the same direction. Cross but don't touch. Across from each other, don't intersect. All right, so it seems overall that we are thinking that they do not intersect. That's the most common response. They do not touch. So really quickly, just a couple of clarifying details. Right here, we say they do not touch. The more mathematical term is what? Intersect, right? So when 2 lines touch, we're saying that they intersect with each other. Really quick note, because I see it up here a couple of times. Where was it? Intercept is different. Does anyone know what an intercept is?
Oh,
Kelsey?
wait. No, I don't.
Yes, you do.
I forgot though.
An intercept.
Oh, the point where 2 lines.
Point of intersection is where they intersect. But
What did
this
you
would be a
ask?
y-intercept.
Oh, yes.
This would be a y-intercept.
Yeah.
What do we mean by an intercept?
That connect the line?
I don't even remember.
It's the point where the function intersects the y-axis.
Oh, yeah.
An intercept is when you intersect the axes. So like here, this would be an x-intercept, right? So intercepts only deal with the axes. Intersections are what we have when we have 2 functions or lines touching or meeting each other, okay? So that's something to be aware of. But overall, we're thinking that they are not intersecting. So that is a good start. We have some more to learn with it. So what do you know about perpendicular lines? Well, parallel, they don't intersect. Perpendicular, probably they do intersect. Okay, horizontal and vertical. Okay. Now, I'm going to give something away in a second because we had this in our last unit. Perpendicular lines, if they're horizontal and vertical, does anyone see anything else about them?
They intersect.
Yep, they intersect. But there's something else. Anyone know what kind of angles they might be?
What it, right
2
angle?
right angles. I mean, 1, 2, 4 angles. 4 right angles.
Okay, so I do see a couple of us that got this detail. They intersect and form 90-degree angles or right angles, okay? So we should already know from last unit, right? And also I'll point this out. This is a right angle, correct? So what do we know about this angle?
It's a right angle.
Why? Say it again. That's a vertical angle. Remember that detail? And vertical angles are always
Equal.
the same.
Equal.
Their measures are equal. I'm gonna introduce a term to make sure we really know this called they are congruent. And we're talking more about what that means in a second. But they're congruent, so their measures are the same. What about these type of angles? What would these be? They are adjacent.
Corresponding.
They're not corresponding. This is something, maybe if you look at it this way, they are adjacent and something else.
Same side interior.
No, you're looking at what we're about to study.
Complementary?
Not complementary, they're what?
Supplementary.
They're a linear pair,
Oh.
which means that they are adjacent and what else?
Supplementary.
Supplementary, right? Linear pairs, those are adjacent and supplementary. So if that's 90, this also has to be 90, right? So when lines intersect and are perpendicular, all those angles are what?
Corresponding.
All the angles are
Supplementary.
what type of angles?
Right.
Right angles. When lines intersect and are perpendicular, they're creating those right angles. What we are going to learn about this unit and focus very heavily on is, well, how does the slope play into that? How does slope affect when they're parallel or perpendicular or neither, okay? So this is going to be a very heavy component of what we are moving into. But let's get started.
They're supposed to give us an extra week, right?
What?
They're supposed to like finish this stuff in a week.
It'll be a little bit longer because of 9 weeks exams, but yes.
Wait, what?
9 weeks exams are next week, bro. So here it is, listen, here is what we're working on today. We're going to explore corresponding alternate interior, alternate exterior, and something called same side interior angles. That's the language on the sheet that we're studying. I prefer the term consecutive interior, and I'll talk more about that later. But we're going to explore the relationships between these angles that are new. We've never studied these, that's the name of the task though. And then we're going to do some parallel line practice in something called the great angle chase.
That's a lot.
It's really not that much, okay? So, here's our objectives. First things first, you have to be able to name the pairs of angles that are created when a pair of lines are cut by a transversal. I believe the term transversals is on here, okay?
Which page?
The orange paper, big ideas, okay? I'm not going to give you everything, but let's say I have these two lines. First off, do those look parallel?
I can't see.
Not really. They'll probably intersect at some point,
No. Come on,
Okay.
lean.
okay? But if I take a line that cuts through both of them, this purple line here would be called a transversal because it cuts through both of those lines. And what's the more mathematical term? There's an I word. They intersect with both of those lines. We go with that idea? So, yeah, you see how I'm trying to like teach, and you know, some people are trying to learn. It helps when you try to learn as well, and it helps others learn. Okay, so there are special types of angle relationships that are created when you have that transversal, and if you have parallel lines that are cut by a transversal, those relationships are even more special. So notice those are both about the same, maybe not exact, but when I cut through here, we're going to explore what happens when you have parallel lines cut by a transversal. And notice that's this part here. I can determine how the angles are related, supplementary, complementary, congruent, etc., when the pair of lines cut by a transversal are parallel. Okay? So we are looking at lines cut by a transversal, specifically parallel lines cut by a transversal.
So what do we put for them instead of which ones?
And we take no shit.
I mean, you could have taken some notes on the orange sheet right now just to make that note about transversal, but hey, what lesson are we looking at? Okay, what's the first lesson in the agenda? Exploring corresponding alternate interior, alternate exterior, and same side interior angles. You know, the white sheet, that is the lesson for today.
Oh, there's the white sheet?
Huh? It says lesson, question mark. What's the lesson?
Oh, it's the white sheet. Not the tan sheet.
This is the lesson. Like, it literally says what at the top?
Exploring corresponding alternative,
Okay.
interior.
I wasn't just randomly putting words up here. This is the lesson that we are exploring when we talk about transversal. Am I just hearing things or does someone not?
Someone not.
I heard someone.
I thought someone not.
They probably right. They claim they don't get it.
Alright.
We don't need it.
So you can put that under the lessons and talk about it there. So,
Put it.
what?
On the next page.
What?
Oh, never mind. I see what page.
So we're right here, okay? So really quickly, I guess I actually, oh no, here's what I need to do really quickly before I even do that. The very first thing I do want you to go ahead and make notes about where it says congruent or congruency, okay? On your orange sheet, I should have clarified that. On your orange sheet, the very first thing there, it says congruent or congruency. This is a fundamental concept to geometry that you need to write down right there. I'm giving you the first one for free, okay?
Where write it in? Definition? Or
Yes, yeah. Okay, so we're going to define the idea of congruency better, but objects are congruent, which I should probably write this where the video can pick it up.
Make sure you write it
I hope I
in.
actually started the video. I think I did.
You gotta write it. You did.
I did. Thank you. Good job, Kelsey. You got me good. All right.
What?
Objects
You don't even know where John
are congruent.
The orange paper, right?
On the orange paper, I would write this under congruent or congruency.
Okay.
But objects are congruent if they perfectly match. Okay? That means their lengths and angle measures are the same. So objects are congruent if they perfectly match. We're going to go into more detail about what that actually means in a couple of units when we say they perfectly match, but as a result of them perfectly matching, their lengths and their angle measures are the same. So to help us get a little bit better understanding of that, this angle 2 and this angle 3 right here, what's their relationship to each other?
Being across from each other.
They're across from each other, so they are vertical angles. And we've always said that vertical angles,
Are the same.
they have the same what? Angle measure. Okay? Vertical angles have the same angle measure. That means that these two angles are
The same.
congruent. Okay? Sir? What? What? You can't see? Sorry, but. Okay. Angles 2 and 3 are, the measures are the same, and they are congruent to each other. Alright? So here's a couple of things that I need you to write down under that part about congruency. This is how we indicate that two things are congruent. So we have angle 2 and we have angle 3. To say that they are congruent, right? So we're saying they're the same. What mathematical symbol have you learned in the past that says things are the same? Equals to, right? However, we're not going to say that they are equal to because we're saying that they are congruent. We put a little squiggle above that. It's called a tilde, I think. Okay? That is the mathematical statement congruent.
Write that.
Put this under the congruent section, right? Maybe even draw this here so that you have an example, right? So 2 and 3. So we're saying that, I would draw it next to there. So we're saying angle 2 is congruent to angle 3. So angle 2 is congruent to angle 3, meaning that they perfectly match. We good with that idea? So that's the mathematical symbol for those being congruent. The reason why we would not say that they are equal is because numbers can be equal. Geometric figures cannot be equal, they can be congruent. Does anyone remember how I would indicate the measure of angle 2 though? What would I put first to indicate the measure of angle 2?
M.
M. And then what do I put after that?
Equal.
Measure of
Oh.
angle 2. Angle
Oh.
2. Now the measure of angle 2 is a number, correct? Yes. So if the angles are congruent, their measures are what? The same, but what's the mathematical symbol for that?
Equal.
Those are equal, right? So the objects are congruent, the measures are
Equal.
equal. We good with that idea? Okay? So the geometric figures are congruent, their measures are equal. Okay? There's one more thing I need to establish with that. Let's say that I have line segment AB, and then we have line segment CD. You see how AB and CD look the same?
Yeah.
So we would say they are what?
Congruent.
Congruent, okay? So how am I going to indicate that I have line segment AB? AB with a line over it. Right? How would I indicate line segment CD?
CD for line on top.
And then how would I say those two things are congruent?
Equal sign with the waves on top.
Equal sign with a wave on top, right? So a line segment AB is congruent to line segment CD. So what do we know about their measures?
Okay.
The measures are equal, or their lengths are equal. Does anyone remember how we would write the length of AB? You don't need the A for, or the M for this, it's just, if you put just the A and the B, that's understood to be the length of AB. So what would I put for CD, or the length of CD? Just CD, and those two lengths are equal, okay?
Thing on top of it.
Nope. Because remember, the figures are congruent, right? That means that they perfectly match. But their lengths, if I were to measure them, I would get a number, right? Numbers can be equal to each other. So their lengths are equal to each other. And please hear me very clearly on this, okay? If you struggle with that, that is okay. It took me months when I was in high school to be okay with that idea. I didn't have anyone explain it to me well. They just said, hey, here's this thing. If you're struggling with it, it's okay. Make sure you ask me to clarify it because I'll be more than happy to do that. We get on that idea? Like legitimately, it took me months. It's not hard. I just didn't have anyone explain it well to me. I'll be more than happy to do my best to re-explain it if you need help with that. We good? All right. All right, I think that's all I needed to cover there. We're going to talk about postulates and theorems later. We'll discuss that later.
We're back on the white paper.
Say again.
We're back on the white paper.
So we're about to go back to the white paper, okay? While I get to the white paper, or for me to get to the white paper, Brooke, can you make sure everyone gets one of these? Okay? Anton, before you leave, can you make sure everyone gets a ruler? Sir? I'll talk to you in just a second. Hold on. Make sure everyone gets a ruler. Ren, can you make sure, start on this side, to give people everyone needs 4 pieces of patty paper. Terrence, I need you to make sure everyone on this side gets 4 pieces of patty paper. Terry, I need you to please, thank you. Okay. Every person needs 4 pieces of patty paper. Yep. You only need 1 piece of copy paper, but you need 4 pieces of patty paper. Actually, Anton probably doesn't need it.
No, boy,
Here, I'll put names on somebody else.
Why you need it? It's not even blue. It's not blue. No, we get the pink.
Excuse me.
Give the plan. Hey, I'm sorry.
Hey, really quick, Terry, everyone needs 4 of these. You gotta figure out something. You gotta figure out something. Hey, Anton, Dee, stop talking. We gotta get going.
Alright, there you go.
No, I got stuff to do. Prepare the Alright, please raise your hand if you do not have a white sheet of copy paper. Everyone has the white sheet of copy paper.
I will be.
Raise your hand if you do not have a ruler. Anton's right behind you. He'll give you one in a second. Okay, now raise your hand if you have not gotten 4 sheets of patty paper. Okay, you need 4 of these sheets of patty paper is what it's called. Yep. Okay, you don't those, thank you. Alright, everyone has their 4 pieces of patty paper? Thank you. You only have 1?
Yes, they do. Look at.
Alright. Hey, I need the talking to stop. I need eyes up here. Alright.
I'm gone.
I know, you have football. I didn't do that. Okay. Huh? What is that? Yeah, it's fine. Okay. There's something I need to say. Okay, really quickly. This is one last thing that I need to note before we move forward. How often do you think you're able to perfectly draw parallel lines?
Never.
Okay? Now, what you are going to do is you are going to use a ruler on the 2 sides, or you're going to draw a line on both sides of the ruler to make it parallel. However, so like, you're going to take the ruler, and you're going to draw, in a second, you're going to draw a line on either side to make sure that they are parallel.
Oh, okay.
Now, what I want to point out to you is, there is a symbol in mathematics to show that things are parallel to each other, even if it doesn't necessarily look perfect. Okay? Do you see?
Oh, I know what it is.
What do you see?
You put 2 lines.
2 arrows to the right.
I mean, like you put like 2 lines on the vertical, going on the line.
Say it one more time.
No,
Is it 2
Vertical
arrows to the right?
2 little like comma things, like.
Commas.
I mean,
Ticks.
like sideways, yeah.
Okay, not for parallel. Actually, I'll talk about that in a second. Parallel, it is this. What is that?
Oh.
Well,
Arrow.
It's a little arrow. It's a sideways arrow. So if I were to draw 2 lines like this, they may not look perfect. By the way, I should have mentioned this. This is still on the orange paper. A note to make.
oh Lord Jesus.
I know, I'm sorry. But I mean, at least I'm just going ahead and giving you this good information instead of making you figure it out on your own. So to indicate that these 2 things are parallel, I would draw 2 little triangles like this
Oh,
that are filled in.
which one?
Parallel lines. Okay? So those,
So I write 2 lines like that?
well, yes, draw your 2 lines, put these little triangles there. Those triangles
What goes under which lesson?
indicate the lines are parallel. Well, hold on one second. I left the lesson part blank because some of these ideas will show up under multiple lessons. And so you would want to write every lesson it shows up under so that you can go back to those lessons to study that concept better.
I can't, yeah, that's too late, yeah. Too late.
Oh, that's also those triangles, parallel lines, indicate the lines are parallel. Can you see that?
No.
Wait, are those lines?
Those triangles
Indicate
indicate the lines are parallel.
You probably put like a dark color in it, so
Well, he just told you what it was.
Like you could have written it down any of the 5 times I said it out loud.
I heard you. Okay, those. Come on, write it. You so smart. Okay, he said those triangles indicate the line are parallel. Wow, look at, he wrote it on the board. That's so crazy.
Okay, so hopefully we can see it from there. Now there is something that we do when we have 2 sets of parallel lines. So let's say I draw a second set of parallel lines here.
Oh, we gotta draw another set on these guys too?
It would be helpful to make this note to yourself.
Yeah, you gonna help me.
Okay. Because this is a different set of parallel lines, I'm going to draw 2 triangles to indicate that these 2 go together.
If you look at the board, you'll see what
Okay,
triangle.
what do the tick marks mean?
We're about to go over that because I forgot to cover that earlier. So please notice, if you have 2 sets of triangles, well, you always start with 1 set of triangles to indicate those 2 lines are parallel. If you have a second pair of parallel lines, though, you're going to use 2 tick marks. What do you think you're going to do if you have a third set of parallel lines?
3 triangles.
3 triangles, right? It's that's all it is. Okay?
So it depends on how many triangles you.
Well, it depends on how many
lines you got.
pairs of parallel lines you have,
And then that's
how many triangles you have. Correct. Okay? So the number of pairs of parallel lines determines how many sets of triangles you have to go up to. Okay?
So what if all of them can't fit on one? You gotta make it big enough?
You would have to draw it bigger. Hopefully you don't get to that point.
Yeah.
Yeah, I don't want to either. Alright? One last detail here. So please notice I would call this line,
That's like a breast cancer sign.
that's a cursive L. That's line L. And we would call this line M. To indicate using symbols that they are parallel, you're going to say L, and you're going to do 2 parallel
Oh, we
lines
gotta draw it?
is parallel to M. Well, I'm just showing you that that indicates line L is parallel to line M.
Oh my god, I can draw it. I didn't know I could do that.
Yes, ma'am.
Hey, I got some bottle of water.
Okay.
I did it.